Alright, so in this video I just want to talk about a few types of equations, and really it's a few types of ways to write them. We're going to come back to this in the coming videos, but right now I just want to introduce them to you. The three types are molecular equations, complete ionic equations, and net ionic equations. Okay, so first, and the best way to show you, I think, is to give you just examples. The first one is going to be the molecular equation. This is the balanced molecular equation. And I'm going to write an equation for the reaction between calcium chloride and silver nitrate. And this is going to be in the form of the molecular equation. We have calcium chloride, and this is aqueous. That means it's a solution in water, plus 2 silver nitrate. That also is aqueous, which is in water. And then the products are a calcium nitrate, and which is aqueous, and a silver chloride, which actually is a solid. We're going to look at a reaction like this more in depth later. For now, we're just looking at this idea that it is called a balanced molecular equation. When we have a balanced molecular equation for an ionic reaction, again, we'll talk about what ionic reactions mean as we talk about these three types, but the balanced molecular equation is going to be an equation where we don't have ionic species or like charges written out. It doesn't explicitly represent ionic species or ions. And what that means is there's no charges written on anything ionic. Things are written like molecules. Okay, and here what that means is we've got calcium and chloride, and they're written in a formula that looks like it's a molecule. Okay. What that means will make a little bit more sense when I talk about this next equation type. The next type is the complete ionic equation. This equation is going to show charges and is going to show what the ionic species are. So here we say dissolved ionic species, ions, which are aqueous substances, are going to be shown as separated ions, not molecules. Okay, so what I'm going to look at is anything aqueous is going to show as separated ions. So the first compound was calcium chloride. It's aqueous, right? It has this in parentheses next to it. So what that means is I'm going to separate the calcium and show its charge with a little aqueous symbol next to it. And I'm going to separate it from the chloride. Now, I've got 2 chlorine atoms here, or ions. So I'm going to say I've got 2 Cl minus aqueous. Okay. In an aqueous substance, where this is showing the number of ions, that subscript becomes a coefficient down here. And then I add that to 2 silver ions. Silver is a 1+. And we have nitrate, which is a polyatomic, so that stays together as its own ion. I've got 2 of those also, right? So if I have 2 silver nitrate, that means I have 2 silver and 2 nitrate. And then on the product side, I have calcium nitrate. This formula was, I have an error there. There's supposed to be a 2 on the subscript for nitrate, CaNO3 So here I have calcium 2+, aqueous, and 2 nitrates. Again, I make that subscript, because it's telling me the number of that type of ion, I make that subscript a coefficient in this new equation. That's also aqueous. So everything that's aqueous has been separated out. Calcium, 2 chloride, 2 silvers, 2 nitrates, then the arrow with a calcium and 2 nitrates. Then I'm left with something that's solid. If it's solid, liquid, or gas here, we don't separate it out. So I would leave in plus the 2 AgCl solid. That stays together. So only something written aqueous is going to end up separated out from its partner. And we'll talk about why that is in the next video. All right, so the last reaction type is the net ionic equation. And this term net is going to mean kind of eliminating anything that is not involved in the actual reaction. So what we say is that in this reaction equation, we eliminate spectator, what we call spectator ions. Okay, and these ions are what we see as aqueous ions on both sides of the arrow. Okay, they're called spectator ions because they don't participate in the reaction. So if I look at this reaction, what I see is a bunch of ions. These are going to be floating around in solution. A couple stay floating around, and a couple combine to make a real product that's a solid. So the ones that stay floating around, these guys, are going to be called spectator ions. They're the ones that are aqueous on both sides of the arrow. The silver is aqueous as a reactant, but solid as a product, right? It's a part of this solid compound. The chloride also is aqueous here, but part of this solid compound. So the chloride and the silver are involved in the reaction, but the calcium is aqueous on both sides, because it says so, and the chloride is and the nitrate is aqueous on both sides because it says so. So if we cancel those out, if we eliminate those, we get the net ionic equation, where we have 2 chloride reacting with 2 silver, aqueous. I'm going to keep my physical states represented, and that reacts to make 2 AgCl solid. This is kind of the main point of the reaction. It eliminates anything that's kind of extraneous. Right? The complete ionic equation keeps everything that's present. The net ionic equation gives only what's reacting. We keep the charges because it's ionic. And we keep the phases because that tells us what phase or what state all of those substances are present in. Those are important things to know. And again, the balanced molecular equation just doesn't include charges. It has everything written in a neutral formula, kind of like a molecule is written. Right? So we're going to talk a lot more about these equation types. I wanted to introduce them at this point, but we will see them again in the next video or two.